bad thing. But you can definitely tell, and at least I hope that you can see as well, the dedication that these students have actually put into their projects. We currently have 16 projects. We have a couple participants. The way this is going to go is each participant has about 6 minutes to talk. I'll definitely keep a stopwatch and let you know when you're cutting close. Most of these are going to be presentations and demonstrations. So, main requirement, project has to be working, and it's going to be working for this weekend's open house. So, in other words, I'm sorry. I'm glad to hear the connection though. But the way we're going to do this, the way we're going to do this is I'm going to announce the people whose projects are currently on, and announce who's going to be going next. So at least they have a moment or two to prepare beforehand. So set things up, make sure that everything is running. So I guess enjoy the show.
I'll jump up here. There we go. I'm going to make a speech. So welcome everyone tonight. I'm Dan Furman. I'm the department chair here in the EC department. This is fantastic. I'm so excited that this event has turned into what this is tonight. So I want to thank and congratulate the leadership of the IEEE Student Branch and the faculty advisor, Dr. Kiekefer. Also want to thank our sponsor, Whirlpool, for their participation as well, and I congratulate all of you participants and thank you for doing this tonight. So I want to repeat one of the things that Chrissy mentioned quickly is the whole idea behind this competition is to create gadgets and gizmos that we can roll out to impress people who might be considering coming to Michigan Tech. I don't know if you're aware of that or not. That's the genesis of this whole thing. So part of the ground rules are that your prototypes have to be working tonight. Yes. Yes, he disagrees. The prototypes have to be working tonight, and you have to be willing to bring them to preview day on Saturday, either in the morning or the afternoon. We'll probably decide how we want to do that, over in the MUB or here. And they also have to be working on Saturday as well. Okay? So those are the conditions under which that you'll have to satisfy in order to claim your prize money. Okay? So I just want to make sure everyone's clear on that point. Okay. Thank you. I'm looking forward to this.
I mean, I can hear you, I just can't hear any distance.
Okay, so we can hear that.
I think we're good again.
We're good.
Hello again, I am Joshua Brody, and I created a binary clock using discrete digital logic chips, and I placed them. So the chips I used were there's a dual 4-bit decade counter, rows of LEDs displaying on or off to represent a 1 or a 0, and therefore displaying binary. So in my classes here at Michigan Tech, I learned how to count in binary, and that was interesting to me. And so I found these dual 4-bit decade binary counters, the 74393. And so I wired them up on my cellular breadboard to count, and so I put my 4 bits into the second 2 bits so I can get 6 bits for seconds, 6 bits for minutes, and then I have 4 bits for hours. And then I have a 555 timer chip tick circuit. Unfortunately, I didn't get a crystal, so it's not super precise. And then to not have to, since binary would count 64, cut off the last 4 bits, I used a dual 4-input AND gate, so I could cut off. So when it displayed 60, which is therefore 4 LEDs lit, it's processed the AND gate and sends the clear signal, and then the next tick to the hours chip, or the minutes of the hours and seconds. And then the faceplate I use is I took apart an old SCSI hard drive, and it was a cool kind of thing, so I have that here. And so I have my LEDs plugged in, and it displays like so. Unfortunately, I do have a glitch in it that I hope to fix, but it is not counting perfectly at the moment. But thank you for listening.
All right, so I'm going to give you about 30-second speech of what this is, because this will speak for itself. This is what was going to be a MIDI orchestra is now a floppy organ. So what it's going to do is it's going to take MIDI input, convert that over into serial output, and turn that into movement for each one of these stepper motors, which will then make music. So it is an instrument, not a speaker. All right, there's much more music that you can play with it, but that is what I have composed so far. You've probably seen this somewhere online where you can look up floppy disk music. People will do this. Most of the time, in order to run 16 different ones, they need to have 2 different Arduinos or an Arduino Mega. This is using one Arduino Uno and utilizing an extra amplifier within the power supply to send a voltage, signal voltage to all of these. So for one channel that I have, it runs 2. That's it.
I'm Chris Jensen, 4th year EEME here at Michigan Tech.
I'm Alex Simon. I'm a 4th year EE.
And we're going to be presenting to you our internet-enabled LED light show. Basically, the project overview, we just wanted to create an LED light show that would span an entire room. So you have a couple of these LED strips which go along the ceiling of our apartment. We wanted to allow for individual control of every single LED. So this is an individually controllable LED strip. We wanted to have internet connectivity so that you can control from anywhere. We wanted also to be able to easily create patterns and add them in so you can expand it in the future. And then, of course, have audio input to create the show. So we're going to move into a demonstration right now because we have a lot of content to go through in our 6 minutes. So when you pull up the web page, this is what it shows you. Basically, 4 buttons. There's the sequencer mode, which looks something like this.
Turn off the lights.
Yeah. Lights. So basically, this is the smooth color fade mode. It basically cycles across the entire spectrum, across the entire system. This is the color build, which builds patterns or builds random colors across the screen. This is the RGB chase. This was our first pattern that we created just as debugging, so we could see what was going on. And then this is my favorite pattern, is an Aurora Borealis pattern. So it simulates the look of the northern lights on the wall. So actually, if I can get it a really big flare. So this would actually, you normally be on the wall, but it's a little bit far away and hard to see stuff. And then This is just a simple color ramp, so it cycles through all the RGB spectrum.
All right, so then we have 3 audio patterns. The first one is spectrum, which we just divide the LED thing into 7 separate spectrums. Each one is represents part of the spectrum. We also have wave, which is a history-based chase. It'll make more sense when you see it. And then debug, which is spectrum with no filters, so that we weren't flying past any bugs.
So this is the spectrum mode where it's just simply divided up into 7 segments. I'm sailing away.
That was, I'm not going to show debug because it looks exactly the same as spectrum, just a little bit glitchier. So this system uses a Raspberry Pi to actually serve up the web page to the user, then uses an STM4 to actually create the patterns and talk to the LEDs. And the audio input is handled through an MSG EQ7, which basically handles the spectrum analysis for us, breaks it up into the 7 bands.
So the STM32F4 communication, that's the microcontroller we used. It communicates to the Raspberry Pi through I2C. We put the microcontroller in slave mode, Raspberry Pi in master mode. We use WS2812 LEDs to transmit the data to the we use the capture compare unit and DMA to output the PWM to the LEDs so they change the color we want them to. And then MSG EQ7 is the analog shift register that we use to determine the spectrum information, which uses a ADC and another timer.
Any questions?
Yeah, did you use a separate chip for the frequency response?
Yep, yeah, that's an MSG EQ7. It basically breaks the spectrum up into 7 bandpass filters at 63, 163, and upwards, and then uses yep.
Does that feed directly into the STM32 or is that into the Raspberry Pi?
It feeds directly into the STM-F4, yep, 32F4. Basically, we're using the clock and the ADC of the F4 reading in the voltages from coming off that.
Okay.
So I'm a 4th year ME. My name is Nick Beal. And during my sophomore year, I messed around with Type 3 hardcode anodizing. And that process is a constant current process that requires 40 amps per surface foot. And then you do that in 30% concentrated sulfuric acid at around 0 C. You got to keep your bath very, very cold, close to freezing, otherwise the acid becomes too reactive and strips off the coating you're applying. So when I originally did this, I borrowed the 7th floor's power supply in order to screw around with it. I did some very small parts. They only required 3 amps of current. Well, I have another project that I need to do that requires quite a bit more surface area and requires 35 amps. And so not only could I not use theirs because theirs is only 15 amps, but it would be much more convenient to have my own. So the end result is this is a 2,000 watt variable voltage, variable current power supply. Still working on some of the nicer output characteristics of it. Thankfully, anodizing is fairly forgiving in terms of like voltage ripple and unfortunately, I haven't been able to load test it all the way up to the 2,000 watts because I haven't been able to come up with a decent power load besides my anodizing tank, which is downstate. So basically, it's a synchronous buck converter. I use a NCP 5104 half bridge driver chip with fixed dead time in it. There are 4 Dell server supplies in there that I've stacked in series, and so they're really nice to modify because if you snip 2 jumpers inside of them, the case stays earth grounded, which makes them safe. They've got great current limiting and voltage regulation on them. And they're very safe and easy to use, so you can't really screw up the power supplies, and they have the added advantage of being really cheap. They're $5 a supply. So for $20, you get 2,000 watts. Then you have to work on your control circuit. I use it's a synchronous buck. So there's 2 Fairchild
055 B15As MOSFETs in there that control the high side and low side. And I measure current with a shunt resistor going through a instrumentation op amp that has a gain of 125 to take the 0 to 40 millivolts to 0 to 5 volts for the Arduino to read. It's all controlled with a Arduino 328 or a Atmel 328P Arduino Uno, but just about any microcontroller can handle this. And then voltage measurement is just done with a voltage divider. I measure the one side of the leads, the other side, so I actually know what the voltage is across the tank, because that's what I care about. I don't really care about the losses inside the supply. And this knob on the front is current, this knob is voltage, and these are individually turn each supply on so they come up in the correct order, and then that indicator light tells me that all 4 of them came up. I got 50 volts on my power rail, and this one actually enables the driver chip, because it's a little sensitive to starting at high voltages because of something called DVDT, which I learned about, which basically pulls the MOSFET on, which if the top side MOSFET's on, you get shoot through, and that's really bad. It blows your FETs because my input filter cap dumps through the MOSFETs at about 1,250 amps and blows them. So that's no good. So quick little demonstration here. That's a 2.8 ohm power resistor. It's the biggest one I could find for the little demonstration.
Please always another finger.
So we'll just put it in the voltage mode by cranking the current knob all the way up. And there's the amp reading is a little off because it's been hit by a few high voltage spikes. But if you knock the bias off of it, you can crank the voltage knob up, and you'll watch that the voltage is fairly steady. It looks a lot better when you put it on a oscilloscope. The voltage measurement here is a little fast. And there's other noise inside of the box that I haven't quite filtered out yet. But right now I'm dumping approximately 700 watts to that power resistor. And if I bring this back down, I can put it into constant voltage mode, or constant current mode. And you'll see that the amps stay fairly constant. So I can't leave it on too long because that resistor's only good for 150 watts, and she doesn't like continuous use. But, yeah, that's basically it. So this is basically, I did this just because I have a specific need for it, and I'm an ME, so not an EE, so maybe this is easy for you EE guys, but this burned up quite a few brain cells in my head. So there you go. Any questions?
Is that tool a valid basis for an arc welder?
You could actually scale this up. So if you put the supplies in parallel instead of series, you'd have 160 amps, which is plenty, and it's actually, you could set up so it's constant current, which makes it really nice for welding because you need an initial spike to start the arc, and then once you have your melt pool there and your arc is started, then you need a lot less voltage. So this would actually do pretty well in that, and you wouldn't be able to blow up the supplies. Just your wire and all of your FETs would have to be a lot bigger. So, or you'd have to parallel up, or put parallel MOSFETs in, and need better drivers and all that stuff. But yeah, you could easily scale this up, and it's fairly cheap on the power side to do so. Because if you wanted to have 24 volts at 1600 or 160 amps, you would need 8 supplies, which is $40, which is pretty cheap compared to what a supply like this would go for on eBay. If you got it used, is probably about $800 to $1,000. So it's a lot better. It's a lot cheaper to mess around with.
So this is the winter spectrum. It's a physical spectrum analyzer. Trend of this show is a lot of LEDs, you'll notice. And I wanted to do something besides LEDs. So we use a physical medium. These are polystyrene beads used to make styrofoam. We bought those on eBay. And we went to the local hardware store, got the acrylic. That's quite expensive for what it is. Got some wood, stained it up. This is scrap metal from the IEEE Lab. It used to be a shelf. Some scrap angle. And old Sony server power supply. Project enclosure from Johnson Controls. Got out of the trash when I worked there, so repurposing and buying new combined.
Yeah. So we're just going to go over why we chose to do a physical one rather than an LED one, because LEDs are all too common. Everyone should build one. So we wanted something that brought music to life in a new way and kind of kept the winter theme that Houghton is known for. So we did some spot testing with duct tape, water bottles, and the fans, and some beanbag fill.
Because we had no idea if this was going to work or not.
Yeah. So we found out that the beanbag fill was a little too big, so we needed beads that would respond a little faster. So then we came up with the design for the final product, which is a nice acrylic and with the base on it. So that's what we got there. And then you want to
So then that's just us there installing all 14 of the fans. A lot of super glue and a lot of cutting, lots of cutting. Yeah, we bought the acrylic sheet at the local hardware store over here. And then we used plastic epoxy to hold the areas together. And then yeah, hot melt, so hot glue to hold it all together.
And it was very difficult getting the cover on the front side back on. Because we all had to work together to get it, all the glue ready at once to create one shot and put that front cover on.
So we made the metal base just out of the sheet steel. Sony power supply, and then the pine that we got from the hardware store. So then we also made a custom fan control circuit based on some perf board. Can you explain how it works?
So yeah, the TIVA C launch pad there, through its 14 PWM outputs, controls the fans through an NPN transistor and an N-channel MOSFET to switch it to ground or off. So essentially completing the circuit for the fan, and that can control when it's on or off to produce our effect.
Our power MOSFETs couldn't switch at 3.3 volts, so we had to have a buffer transistor to drive them.
So it took a while. It was a job.
Yeah, many nights here.
Yeah. So you want to?
Yeah, so we used mentioned Texas Instruments. It's a TIVA C series launch pad, which is ARM Cortex M4F based processor, and took advantage of the ARM Holdings DSP libraries to have some very efficient FFT algorithms implemented, and along with the TI's peripheral driver libraries, we're able to capture samples from the analog digital converter at 44.1 kilohertz, and then process them with a 512 pin FFT, and then divide that down to drive the individual motion control PWM modules and run fans.
So we just had to figure out what optimal frequency width was for each of the bins to show music visually. Because if you just do a linear or logarithmic, it didn't really translate well. So we had to do testing for that, and then testing on what speed to run the fans at so that it hits the right level. So that was part of it as well. So now we're just going to show you how it works.
Sorry.
And the vision that was planted in my brain still remains within the sound of silence.
All right, so that's it. Any questions?
What's the fan specifications you use?
They are 12 volts at 1.2 amps. We chose server fans because we wanted high current draw to get them to spin up as fast as possible. So
They're 60 millimeter square fans.
you can't see them because we blocked it off, painted it in the bottom. Any other questions?
Any thought of the delay across between the inputted music to the actual?
It's big.
Bands?
I mean, you could get more powerful fans. You could have a fan up here.
Why can't you just offset it?
Or delay the music? Buffer.
Yeah,
Play the music.
we did consider that. You could add a delay loop using another audio channel and software.
I was thinking you could put some LEDs behind it or underneath it so they change colors as they.
Keep it snowing. I like it.
So is this an original idea, or did you see something like this?
Yeah,
We've seen a few similar people that have some similar
yeah.
stuff.
If you search physical spectrum analyzer, there's like one guy actually in Japan. I emailed him and I said, "Would you mind if we took your idea and made our version of it?" And he said, "Sure. Send me the video when you're done."
Okay.
So we have seen something similar, but his didn't have the separate columns. So when his went off, if one fan was blowing, it would blow all the particles to the other side, and there'd be nothing over here. So we separated them.
What's more complex is water shows that will
Yeah.
do something similar. So, but this one I haven't seen the shows.
Yeah, it's a creative idea. I like it.
Thanks.
So I had I'm presenting my Ultrasonic Cleaner project. I couldn't find a card to bring it down at the last minute. Whatever. Most of what I have here is a schematic for it. Overall, it I had a problem with the gate drive circuit to provide power to the ultrasonic cleaner and producers. So what I wanted to do is I wanted to deflux PCB boards because after soldering there's lots of flux and residue on the boards. So I found this ultrasonic, or this heater and cooling stainless steel tank, and I attached 2 ultrasonic transducers on it, which look like this. What you can see here is they're piezoelectric transducers. So you got like a big piezoelectric crystal right here and 2 contacts. Kind of back. So I found the most simplest model I could find, which is just a capacitor in series with a resistor. There's lots of literature that go way more in depth than the non-ideal aspects of transducers, but this is the most simplest one I could find. So essentially what I'm doing is I'm switching 12 volts through a reversed ATX transformer. So on the low side, I'm switching through 12 volts on the 12 volt cap of the transformer, and then it's outputting through the mains side of the transformer to the transducers, which creates pretty high voltage to drive them. Big issue I had is with the gate driver. The signals would, or the gate signal would, I tried to drive back my controller, but it turned into like a triangle wave, which isn't good. It should be like a square wave. But the gate driver kind of turned into a square wave, but there was, when the MOSFET should have been off, it partially turned on due to ringing and other aspects. I kind of had the same problem as Nick with the Anodizer supply, thinking maybe the inductor would turn on the MOSFET due to the capacitance of the MOSFET gate. So it partially worked, but it didn't fully clean anything. So I'll have to investigate more into the gate driver, see if I can do more.
If you want to wait a moment, Mark is actually bringing your cleaner down.
Oh, it is?
Mm-hmm.
Okay.
I apologize for that.
That's about like 100 pounds. Yeah,
How did it work
it's got
out
like
then?
air conditioner on it too,
Huh?
and a heater coil. I guess you can talk more about ultrasonic cleaning in general. So ultrasonic cleaning goal is to create cavitation bubbles, which are due to the sound waves. I guess like the sound waves do something which create cavitation bubbles, which implode and then they nice.
Yay!
Would you like the oscilloscope too? Would you like the oscilloscope?
Don't smash your fingers.
It's up to you. I didn't have probes down. I should have. It's down here.
Did you need that? I don't think so.
Tell us about it.
There's the two ultrasonic transducers right here, which are the capacitors of the resistor. Here's the ATEX transformer, wired backwards. I used the TI launchpad, just like in the winter light show thing. It's a pretty versatile chip. And on the back, I've got the voltage regulator, and then there's a gate drive transformer, or a gate drive chip in there too. Anything else?
I do have a question.
Yeah, question.
What kind of metals would your cleaner be able to actually clean off?
I guess just about anything, I guess. The cavitation bubbles implode and then they can blast stuff off of any surface, I guess.
So not just metals, anything then.
Mm-hmm.
It's actually pretty impressive.
Yeah.
Is there certain things it can't clean off of, like dirt? Is there certain kind of dirt or chemicals it can't clean off of metals?
I guess a better way of asking is, how large of a particle size would it be able to clean off?
What kind of particle size?
Yes. What range? Like rather large pieces, or are we talking like germs and dirt?
Pretty small pieces like oils and dirt and flux and different contaminants. You can like microscope sizes them.
Alrighty.
I think I'm done. So.
Hello, webcast people. My name's Cameron. Trying to be short, sweet, to the point with this. I built a quadcopter. I started getting into this project because I really love taking video, and frankly, to buy something that's actually a quality video drone is just in the way too much money range for me. So I wanted to buy about a $4,500 professional 4K quadcopter that would allow me to have all sorts of bells and whistles. And unfortunately, I'm not made of money. I go to college. We all know the story. So I decided to build one for about a quarter of the price. And this is where I have ended with the flight controller is one of the most important pieces of the quadcopter itself. And they're really expensive in the range of, for what I wanted, between about $500 and $800. So I took a $24 Arduino Uno, put together some flight code after learning how to do it from this crazy German guy, and here it is. So it works pretty well. You can see up here, these are some of the original pictures there, and then on the right, the middle is more now, and then it's got some LED light strips on it so I can fly it at night and actually see what it's doing. I pretty much went over all of this. So a couple of the functions, it's got, right now the only sensor on it that I really use is just a single 3-axis gyroscope for any of the angular rate changes that any misalignment of the propellers or the motor mounts can all accumulate to. Without a correctional software on there, this would pretty much kind of lift off and fly off in the distance and then normally hurt someone. Doesn't really work out well. So it's got just the gyroscope to correct for any sort of rotational errors. Then it uses the Arduino Uno to run the flight code. It's about, I want to say it's about 300 lines of code, and it runs that at 250 times a second. It's a 4 microsecond refresh rate, and how often it calculates using a PID controller, which is a proportional integral derivative calculation that calculates, how did it, what was the last error, kind of try to predict the next error and make it really stable. You can sit there and play around with those values for a long time to make it as stable as possible. So then there's just a little bit of the code there. The Arduino Uno runs off of, or the way I control it, it's based off of interrupt pins. So it'll just keep running the code over and over again until I change the sticks on the controller to do something different. And then once it hits, or once those interrupt pins realize that it's doing, that I'm trying to control it and do something different with it, it'll change the base values of the PID integral so that way it runs differently and will continue going forward. Current things that I'm working on right now is getting an accelerometer into it, so it'll auto stabilize itself if I push it and make it go forward. Right now I have to make it go backwards so it will come back. If the next goal is to be able to flip the switch, have it fly forward, flip the switch and just have it auto stabilize and stay perfectly level. But right now I think it flies pretty dang good. So just before I give you the quick demonstration here, these are 2 videos I took. Oh, Internet Explorer.
Why?
Gosh, that's bad. Yeah, right there is the reason. But right here's, oh gosh. Right here's a picture or a video of tech that I took with this drone. I want to say that's probably between about 150 and 200 feet in the air. It's kind of a pretty picture.
Awesome.
Next one is a night shot. This one I got higher than my own comfort level, but it still turned out really cool. So that's tech at night. And for reference, this is Wadsworth Hall right there. You can't, in Hillside, the top of Hillside's right there. So just kind of a different shot you never really see. But so, yeah, now I will demonstrate. When I turn this thing on, it takes a second to calibrate. It takes 2,000 readings of the gyroscope and sets that as the base value. And then also I thought it would be fun to take video of everyone while I do this.
Ooh.
Move the mic.
I'm gonna be on camera. I better get my makeup ready.
Move the mic.
Yeah.
Move the microphone. Oh yeah, let's not kill things. All right. So.
All right, is that good?
Is everything working the way I want it to? I don't know. Is it? No, it's not. I must have jiggled it. It doesn't like to be jiggled when I first turn it on. So, yeah, last night my LED controller crapped out. Now I can't change LED colors anymore. So that'll get fixed soon. Hey, there it is.
Just FYI, it's a minute and a half.
Oh, cool. So I'm doing good on time.
Fantastic.
Yay. All right. So it's got safety precautions on it, so I can't just up the throttle and it just takes off. So it actually has to have a stick position set to be able to turn the motors on. So, and like I said, if you're uncomfortable, don't try to hit it. I'll sacrifice myself before I sacrifice you.
That is loud.
As you can see, it's pretty stable.
Can you get it to hover in one spot?
What's that?
Can you get it to hover in one spot?
That's what the accelerometer is to help me do. Right now, this is all me. So,
I have a question.
Yeah.
Did you write the PID loop yourself?
The PID loop I found online. I used the calculation, the formula for it, but then I went ahead and threw it into the Arduino line by line to actually make it work. And it's a total not fun mess there. Just, yeah, graphs and looking at all the graphs, honestly, it's awful.
How are you getting the signals from the radio or the handheld radio into the Arduino?
There is I bought a Futaba transmitter. This guy here is the transmitter, and then on here is a small receiver box. The receiver box then sends its input to the Arduino, and then the Arduino actually outputs the square waves that go to each individual speed controller.
Okay.
What's the range on the food saver?
Right now, I've never taken it as far as I think it can go, but from all the testing I've done, I want to say it's about a mile. So it's pretty decent. It's pretty decent range.
What happens when you turn off the controller?
Bad things. Actually, it's not too bad. If for some reason the controller, I flip it off or something, it just retains the most recent setting. So if it's just flying up, it'll just continue to fly up. If it's flying forward at someone, well, that's a little bit worse story.
Today, I had a music sync LED system idea. So this started off this past summer, and I was bored after work in Chrysler, and I was just like, what do I want to do? And I'm like, I want to make some music, or I'm going to make some LEDs flash with music. So I'm like, okay, ideas. I can input it through aux, and I was like, well, we can use Arduino Pro Minis or Arduino Unos. And I started doing that, and it turns out that you can't actually, the Arduinos aren't powerful enough to do a fast Fourier transform and actually get the bins that you need. So then, for the first phase of my design, I just kind of used an Arduino Pro Mini with a sound sensor. So like it would when you clap or heard anything, it would take the audio in, and then it would just send a random value from 0 to 255 to the 3 colors, the 3 RGB LEDs with the NPN transistors. And then it worked, and it looked cool, but it didn't do what I actually wanted it to do, where like the intensity and it matched the beat perfectly. So then the next thing I did was have an aux in with a MSG Q7 chip, similar to them. Did first though. No, but it basically splits it up into 7 bins, like they said, and I take it and input it into the Arduino, and then the Arduino takes it and remaps the values to 0 to 255, and then I take the low frequencies, the low bins, and send it out to red as base, the middle frequencies, and send it out to green for mid, and then the last 2 bins for treble to blue. And so this worked great. And then I was like, okay, well, what else can I do to make this even better? So my third phase actually made it Bluetooth. So now I can put this anywhere, my apartment or the fraternity house, and I can just put it up in the rafters, wherever I want, and it actually works. So then I took that, and so this is the circuit that's up there right now. And basically, it inputs audio. It has an aux port, for out if your computer cannot do a dual output through Bluetooth and its speakers or headphone ports or whatever. So if you want to connect up to your own system, you can. Goes into the Arduino, sends out the signals, like I said, goes through the NPN transistors and goes to the LEDs. So then the fourth and final stage is what I passed around there. And I bought the Bluetooth module from China. And it turns out the pinouts on their website are incorrect compared to my breakout board, which has the pinouts going to the Bluetooth module. They're off by 1 on the whole left side. So my PCB is actually being remade. It should be done sometime this week, so hopefully tomorrow. And I'll hopefully get it working with just that. But I was going to show you my code, but I couldn't actually hook up my computer directly to it. So I guess I'll just go straight into the demonstration. Here's just going to show you. So like currently it's just the blue.
Towel on it.
What?
You still have a piece of paper on there.
Well, to diffuse it because it's really bright. So I tried to cover it up with the light to actually show the color. You can turn off the light maybe, yeah. I feel like there's no...
I'm getting a full blast of the color.
But anyway.
Full color.
But if you go to like... Oh, I missed the bass drop. Right here. I love that part because you can really see the different colors in there. So you can see the red come in for the bass when it comes in. And this works for not just EDM music, but a lot of other kind of music like this where it just has a lot of different changing songs. So this one's one of my favorite. Then here's another really cool one. Because you don't really get to see the solid blue in the beginning there. That's really cool to see because it's just showing that it's the very high frequencies that are coming through. The beginning of this song is also really cool, and then I have one last one. You get a lot of purple, showing that it's both bass and the treble. Let's continue going to the next one. But yeah, EDM music definitely is the best to show like the start stops, and I guess I should have had like a stroke, what's it called, epilepsy warning, but yeah, this is my system, and I'm hoping to get into that PCB and be able to,
I think I'm tripping.
So, yeah, thank you.
Beautiful.
One last thing. I have a switch on here that actually makes it go through the rainbow as well, but I don't actually have the switch on here. I have a switch that goes into one of the digital inputs to the Arduino that will let it go through either audio or it cycles through rainbow. Any questions?
How did you, how did you settle upon turning? I noticed your LED strip is flexible. Is there a particular reason for that?
Yeah, so like I actually have this like hooked up in my room behind my monitor and my TV, so it projects up. That's kind of why I have this to diffuse the light, because it looks really cool in my room when I have it projecting on the wall, or like if I have it underneath something like around a table, I can project it down onto the ground, and it has, shows the color. Maybe once I get some more money, I can actually make this with individually addressable LEDs and have it do multiple, have multiple arrays of LEDs and have them go up and down with the wave spectrum.
So my goal for this project was to create an FPGA external processor so I could do computations faster on the FPGA instead of on my own computer's CPU. So for starters, background, an FPGA is a field programmable gate array. It is basically a whole bunch of logic circuits that you can set to any logic components you want inside, so you can perform fast operations with the logic circuitry. And because it's logic and not like a computer CPU, you can perform many operations at the same time in parallel, which should theoretically make stuff faster. And my purpose, I already said. So the communication path I decided on was communicate from my computer through an Arduino to a Cyclone 2 FPGA that I got online. And the way I set up communication between the computer and the Arduino was basic serial through the USB cable. And then between the Arduino and the Cyclone 2, I had set up a 8-bit system where I could send 8 bits per clock cycle to the Cyclone 2, and from that, it would take in that data, do the computation, and then send it back to the Arduino 8 bits at a time. I had to put a resistor divider network in because the FPGA is 3.3 volts and the Arduino is 5. So that's what it was supposed to do, but I was able to communicate from the computer to the Arduino and the Arduino to the computer fine. I was able to send values from the FPGA to the Arduino fine, but I couldn't get a value sent from the Arduino to the FPGA. So instead, I made an Arduino external processor by basically cutting out the FPGA and doing the remote processing on the Arduino. There is really no practical application to this since the Arduino is super slow, 16 megahertz compared to gigahertz, but it could be done with a different kind of processor or in the future sent to the FPGA. This is what the system looked like with the FPGA. You have the Arduino with your 8 bits going through the resistor divider network and to the FPGA right here. And then you had the result 8 bits coming back to the Arduino right here. But I'm currently only using the Arduino because of the before mentioned problems. So using this application I wrote, you select the COM port that your device is on, and then you select your operation. This is right now a simple little processor that I implemented, but the point of this is you could implement whatever you want on the FPGA or, in this case, the Arduino. So I can cycle through different operations. And notice this is the bit sequence getting sent to the Arduino and how it changes as different numbers are entered. So let's say I want to add two numbers together, 2 plus 1, and then I hit compute. It goes to the Arduino and back, and I get, or I subtract and you get 2 minus 1 is 1. Now if I add those two, I get 3.
All right, good.
Any questions?
Instead of resistor network, did you consider just using a logic translator?
I did have one of those, but with all the problems I was having with the FPGA, I thought that might have been part of the problem source, so I went to a resistor network to make that, to try and take out one more possible problem source.
If the FPGA was running at 3.3 volts, how do you get the message back to the Arduino?
The Arduino actually only needs 3 volts in order to read a high, so it can read the signal from a 3.3 source.
I've had problems in the past with that, but yeah.
I was able to get values from the FPGA back to the Arduino fine when I hard-coded them into the FPGA software, but I couldn't ever transmit to the FPGA.
Okay.
Any other questions?
A couple of months ago, I was going to make a theremin, but I couldn't get this thing to work, which is the thing that makes it a theremin. So instead, actually, does this fit in here? Oh, it does. Oh. It doesn't fit all the way. Okay. So you got 9 volts in over there. Pretend it's on screen. So I have a 555 timer, and I have an LED and a piezo disc as the speaker. These two are potentiometers. One of them is a trim pot, and the other one is a 500K linear potentiometer. And so it is a slide whistle. I can turn it down. The trim pot is 5K, I think. Yeah, and there's about a 100 ohm range that I can operate on for that. So I hot glued the battery to a piece of cardboard that is taped onto my broken breadboard. See the scotch tape. Piezo discs. Oh, I should have printed out the receipt for those. Then do that after this, because technically we're supposed to bring the receipts to this. But there's the 555 timer on one of those things that makes it easier to solder it to stuff. I did have a perf board, but I'm not good at soldering, so I ruined the 555 timer, so I just put everything in the breadboard. A couple of resistors in here. Actually, that resistor adds to this one. Actually, no. Both of those are this potentiometer and the trim pot. And this one is, I think, the one between threshold and discharge. I think those stand for it. Yeah. Also have a button that is not listed. Button goes right there. And yeah, that's my presentation.
Okay, so this is IoT, mostly there because of the pun. So, let's see. It's pretty much just an internet-connected teapot where, yeah, so there's a few other ones that exist. There was one called YPot, which the information was kind of iffy about it. It was a suspended Kickstarter. I could not figure out why it was suspended. And then there was some Russian proof of concept. It was kind of poorly translated. It was pretty much just a computer that sent serials to an ARC controller. And then HTC PCP Air 418 on a teapot is if it's a coffee pot, not a teapot. That was an April Fool's RFC, but it's on the listed HTTP error codes on Wikipedia. Let's see. So the way we did it is with a particle photon. So that is a so particles are a set of microcontrollers for IoT. It's platforms. They have stuff like cellular connections or Wi-Fi connections or Bluetooth connections.
What is IoT? Just to clarify.
I could think to explain. IoT is the Internet of Things. It's a group of anything that's internet connected. People tend to rule out like actual computers and stuff and list things like a teapot you can turn on wirelessly. Instead, the definition's always a bit iffy, but you can pretty much argue anything with an internet address is on the Internet of Things. And so, Particle is a set of microcontrollers to help with prototyping for that. We use the photon, which automatically integrates with if, this, then that, which is an internet platform to automate pretty much random connections between internet things. So like you could say, if I receive an email, post to Twitter, or if somebody posts on Twitter, post to Tumblr. I have a few bots that do that because I don't follow Twitter. But it also integrates with photons. You can, it lets you have subscribe things that subscribe to functions and events. So I have an app somewhere that will connect to the IoT and let me call a function. So actually, the way it's configured is on the actual particle photon, we configured two functions, set on IoT and stop on IoT. They take a parameter of set takes a parameter of temperature, stop just ignores all parameters. And so that was all coded in what's pretty similar to Arduino code, which is kind of like C, effective C. But so you set those up, and then you can set buttons pretty much. So let's see, this is on the far side. You just press it, and it will turn on to the right temperature for black tea, probably, or turn off. Okay. Thread wires are important. So, we had to tether it to my phone because we didn't test with Michigan Tech Wi-Fi, and we couldn't bring the IEEE Wi-Fi down here. So it's connected. Theoretically, you press the button and it'll turn on the teapot to the set temperature 99 in this case. Oh, there it goes. So there's an LED here that's green, meaning it's turned on, and the original LED from the teapot is there. We have the photon pretty much just controlling the fancy relay, and there's a power supply in that box as well. We haven't quite closed it up just because we haven't figured out how we want to present a user interface here, because you probably want to be able to turn it on at the thing as well as with your phone. And if your phone's dead, you still might want tea. So it has a 1-wire temperature sensor that right now we just stick into the top, but we will be integrating it into the base because you can pretty much make that work. It's just a 1-wire temperature sensor, which is an interesting protocol that can support as many devices on one data wire as you want. It just keeps asking, is there a device in this half of the address space? If anything replies yes, it keeps dividing it until it finds one address. That way, any number of devices can be on the same bus. Theoretically, you can also put power over the data line, which is kind of cool. So we actually need 2 wires despite it being called 1 wire. Most things take power wires as well, though. So it's theoretically heating the water until it hits 79 degrees, and then it will turn off automatically and send a notification to your phone saying that it finished. You can also just stop it, and it will hopefully turn off fast enough to not light it on fire. So far, it has not caught on fire. We were pretty happy about that one. Hey. So, yeah. Any questions?
Is that Celsius or Fahrenheit?
Celsius. Why would you use Fahrenheit? Hold on.
Do you expect future developments in a coffee pot?
I do want to implement HTTP error status code at 418, 419, which one it is. But we wouldn't be able to do it with this, with IETea, if this and that, we have to do it some other way. Like the Russian guy was implementing an actual web server and then just sending over serial to some mic controller. If we did something like that, we could very easily do stuff like that. But, I mean, a internet-connected coffee pot was already demonstrated at Winter Wonder Hack a few weeks ago by Tate, who just took a Keurig and did this. That was after we had done the original concept for this, so he was totally stealing our ideas.
I'm going to cut you off, okay?
Hello again. So I created some RC airplanes. This is sort of a continuation of a hobby through high school. I got a basic little RC plane that I learned on, and then I saw how expensive some of the larger, bigger models are. And so I went into buying the components and sort of building and designing my own. It was sort of a cheaper route, and it was a fun experiment and also a challenge, and I learned a lot. So this is some of my scrap that I had, my previous prototypes. And so this is a picture of this beginning to come together. So I have RC plane, and I have a K2 or KFM2 airfoil, which is basically a step. And that's some of the research that I had to find a simple airfoil to just sort of make it out of foam without having to mess with a big foam wire cutter, and if I never really got that to work well. So I've been doing some simpler builds, just sort of layer of tape, give it a little bit cleaner leading edge. And so this is the main project that I worked on, is getting this sort of to look nice and designing sort of a final version. So this is me starting to put a couple more components on. So you can see there's the motor and prop near the back, the ESC towards the center, the receiver next to it, and then the battery up near the front, and the servos out on the wings. And then I had a nice time figuring out how to work a hatch to be able to put the battery in and out.
Watch out. It's falling. Yeah, you're falling. Yeah.
And so there's also some sanding I had to do, so I had to get some sandpaper and make some nice round edges to have some better airflow. Some more of my tools. I had to sort of manipulate a holder for some razor blades so I could cut the foam and bevel it. I have a nice way to do that. This is me starting to put the tape on there. There is the almost finished. This is basically just the airframe there. And there's the bottom. And now I have a short video of some excerpts of some of the flight video that I took. A bit windy.
What's your range?
My transmitter is, I believe, 3,000 feet. The receiver.
How many times have you crashed it?
I have not crashed these models yet, but I've crashed many, many models back at home. Learn from my mistakes.
Yeah.
Had some pretty clean landings with these. Remember to. I learned some acrobatics in my experiment, and that those are also sort of the reason why I crashed many times. Is I went a bit too, I got too excited with some acrobatics. Here's the This is earlier today in the snow and the wind. Having some fun up in the sky.
Today?
Just so close. Go ahead and turn the lights back on. I'll give you guys a short spin of the prop.
Okay, you have about a minute and a half, okay?
You can see here, I know, power to receiver, and so some of the things I had to do is since controller normally have one servo for like rudder, one servo for elevator, and one servo for ailerons, and so since I only have 2 control surfaces, I had to have a wingtail next, so that when I pull back on the controller, I get both to climb, but then also be able to turn the plane. And so, we'll do that. I have vertical takeoff capabilities. Is there any questions?
How fast do you think you can get to?
With these, I've brought them up nice and high and brought them into a dive, and I get going pretty fast. I'm not sure how fast, but at a point, these, I get some turbulence with how I cut these hinges, and so these oscillate very, very quickly, and I've ripped them off before and had a fun time trying to land with only one control surface on one thing.
Can you do a barrel roll?
I can.
Awesome.
Saw some of those. I did a little bit.
So, I wanted to make sure that I made a project that was actually somewhat applicable to like both some applicability and some like wow factor kind of thing and coolness. As you can see, there's lots of like mechanical parts and stuff, so it looks pretty cool. But it's actually useful. I originally was going to go with a resistor sort of design using magnets to pick only one resistor at a time, and I tried using that in a lot of different ways, and it's really hard to get one resistor at a time. So what I ended up doing is making like a clip almost kind of like a machine gun, and it just fits the resistor cross section and then down so they slide down the clip. So there is always the argument of, well, if I like have this resistor, the time that it takes to put it in the clip, is that enough time for me to just read it anyways? Because if it is, then it's a completely invalid machine. But right now we kind of have the ability to load like a bunch at a time, so it still is faster than reading them. In the future, I want to get some kind of a system on here that you'd be able to grab all the resistors and just shove them in there in kind of a bin. And then these actually are vibrating motors. I'm not running them right now, but those in that case would help the resistors to organize themselves and just, I guess, just sit in whatever kind of formation of container that you have, and they kind of will sit to the bottom and organize themselves during the vibration period. I'm using an Arduino Nano and 2 Holu DR885 stepper drivers. These are bipolar stepper drivers, and they have the capability of micro step down to 32nd of a step, I think, and they're pretty high current. I'm running this stepper at 0.4 amps, and this one at 20 amps, and this at 0.4 amps. The way it works is the stepper will come down, hit a limit switch, and when the limit switch is triggered, then it notifies that that's in that position. It'll come up to the pick position, and then the servo will close, grab it, and the actual stop at each one of these terminals. As it stops, it'll pause, wait for a resistance calculation with a voltage divider using these 3 separate resistors here. You want to measure a 1 ohm resistor and then 1 mega ohm resistor. The problem with that is the resolution of an Arduino is 1023, so I don't know how many bits that is. That would mean that you wouldn't be able to measure a million ohm and a 1 ohm resistor using only 1 voltage divider, so that's why I had to use 3 different ones. I have it spread out, so I think I have per separation I'm using at least is like around 30 to 29 steps on the steps of the 10.4 like band or whatever on the readable voltage pin, so analog pin. So it's somewhat accurate, but I could only for simplification I'm using E6 series resistors, which is 6 per decade. If you're a hobbyist, that's probably okay. I don't know. I mean, it depends how particular projects you're doing, I guess. But if you wanted to, I originally had the E12 series planned in here and had twice as many separators, but it would have been more difficult to get everything to line in the right spots. I simplified it, and if need be in the future, you'll just be able to increase diameter and have more types of services. So there's 3 different levels. So this will pick it and drop it in one of the 3 corresponding things. And this will be able to step to the spot you want it. Both these, this has only a switch to home, position, right there. So let's try it. So home, grab the resistor, measure, and then drop.
I can't see.
Oh.
You designed the carriage yourself, didn't you?
All the parts are modeled back, yeah. This is entirely original modeling. I've been looking and researching on resistor sorters, and it's difficult because most of the resistor sorters I saw online there was one professionally produced one, and it was only the square surface mount kind that are really small. Those are all the exact same size and the exact same square, so they had a spiral vibrational built, like bolt feeder systems in factories, and it could get it so they're all lined up, and then they could tap off and then put it in the bins. But this is a through-hole type, so it's kind of a different kind of game. Yeah, there's still some issues with the grounding and everything, because if it's a through-hole, there's not really a defined shape to it. So
I have a question.
Yeah.
It spins one way and then it spins back around.
No, right now
is it resetting itself each time?
The voltage readers aren't actually working right now. This doesn't provide enough pressure to get accurate reading. These are just basically torsional springs I need to wire, and they have to have a little more pressure in order to get accurate reading. I wrote all the code for it, so I actually just found with a spreadsheet on Excel which voltage values were needed to place a resistor into the corresponding category, and then I put those in just if statements on it.
So what's the probability of error?
What's that?
What's the probability of error that you're gonna get in the wrong pin?
I mean, right now, 100%.
Seconds left, okay?
It's still pretty neat. I mean, it's an amazing project.
Yeah, I mean, if I can get those to, I'm a mechanical engineer, I'm a minor in electrical, so I have some understanding of that stuff, but I'm not as good as the EE would be at knowing how to sense the resistance values all perfectly. Well, anything on that note? There we go.
All right. Hi, everyone. For the most part, when I came here, I wanted to do something, simple within my range of knowledge, since I am very little. Morse code is something very interesting, but not everyone has time to go and study it. What I have is a very simple range that takes an Arduino language, takes the Arduino and presents it using 4 displays, 4 LEDs in 2 rows, one for dots and one for dashes. I'll turn this around. The dots are the top row and the dashes are the bottom row, and it will display essentially anything you put into it. All you gotta do is just type it into a keyboard. The inside is a little messy. I have a 9-volt battery. God, let me get this. Oh crap, I can't get to it. I have a keyboard. All right, if anyone can see, there's a 9-volt battery down here. Sorry, I got back it. And it's running straight. The 9-volt battery is going to a regulator, which is going right into this power cord, right into the Arduino. Right into these pins, obviously. I go and plug it in. The code, since I am not a CS major, I had quite a bit of help with the code. And let me go and type something.
For reference, what are you typing?
Hi, and how are you? As you can see, it does a second delay. And it'll essentially type in anything up. The library is set up to 500 characters. And it'll run in a 5 loop, but you don't have a cancellation. I'll try and add that in, but it will run 5 times through the whole loop, and then it will reset itself to a blank. So technically 499. But that's essentially what it is. You can type in anything you want. Just gotta wait for it to do it. For anyone who wants to check my accuracy, I have that, so you can check how accurate I am.
Would you be willing to type, have it to display SOS? Because I think everyone's very familiar with that.
Yeah, I just got it with that long message I typed.
It might be better to unplug it.
Alright. I need to get that cancellation in. Alright, so SOS. Oh wait, what?
Is it good?
Yeah. No, that should be.
That's SOS. Yeah, it's definitely SOS.
Oh yeah, I'm thinking of it there. But yeah. That is a very simple idea. Future iterations will have me doing it backwards compatible, so Morse code to English, but I'll need a screen for that first. Or maybe just more LEDs. But that is a fairly simple project. It was mostly for me to study and learn Arduino language and more circuitry. You major got to do something. And that's my presentation.
Thank you very much.
Okay, so I'm Alex Donovan. I have a 10-channel Arduino controlled light show. And so these are all the 10 channels. All just LED strips. So it's controlled by a serial from my laptop. And basically all it does is it uses the Arduino to turn on and off solid state relays. So it's pretty simple. It just takes a 5-volt signal and it turns on, and then you have AC coming out of the different ports at the bottom here. Here's the inside of it. It's pretty well wired, and Arduino's on the left. It has different wires that go off to the solid state relays, and they turn on and off AC power to all the different little switches. So it's also fused, so it's like safe and stuff. What? Smart engineer. Yeah, thank you. Right now I'm using a software called Vixen to control all the different lights. Different people can use this software to make their own light shows and stuff. And that's kind of what I wanted, was a light show that I could control very specifically. I was using a program called Audacity. They have like a Fourier transform. You can find out what the beat is, and then you can find out where the marks are to kind of like figure out where to light up things and when to do that. And that's one of the things I did. So it like helps you with programming all the lights. Now the light show. All right. So.
All right, that's it.
This is a small spy robot made from an old RC car that drone guy over there. I didn't know until now that he threw it out, but it runs out. Okay. It's very. So basically, the Wi-Fi broke on us. Yeah, we had this thing doing the Wi-Fi, but it broke on us in the last second. So yeah, and there's no Ethernet port in here. So apparently, we have to. So we have to. I don't know. Figure it out, I guess. But so this thing is basically we salvaged the old frame of the robot, and if you guys could see this little side of the breadboard, it has like a H-bridge configuration that's controlled by the Arduino here, and then it also controls the camera right up here, and it's all communicates with Raspberry Pi through just I/O. And and then these are all 3D printed because everyone wanted the cool webcam mount. But okay, and the webcam is it works, so that's cool. Yeah, hold on a second. Yeah, and it's all controlled with like an Xbox controller. And just hold on one second. Ram one. And it's got lights too for the dark.
LEDs. You need more.
I know. That's it. You guys aren't gonna see anything. Oh, this isn't gonna happen. Everything broke. So this was kind of a last minute project. We just kind of wanted to do something for fun, and then
What? Frankenstein's bot failed?
It was working, just kind of like circumstances. Things broke. Everything broke the last minute. Yeah. Which sucks.
No, Frankenstein's bot.
We threw it together as fast as we could. What we do? Okay, here's the concept. So basically, it was just kind of like the most classic robot you'd have. Just it has this webcam. So we just did we basically connected this whole thing through basically we have one kind of master computer, then we have kind of like this little slave guy, and what it does is use UDP protocol to send it a byte array, and then what it does is it just takes that and it takes it in the Raspberry Pi, and then it just turns on the GPI opens to what we need, and it goes to the Arduino, and then outputs what we need through the breadboard, and then basically we just have everything moving like this, and then we have this says servo, it says everything's servo connected, so what it does is it rotates, it actually does work. I don't know if this doesn't work right now, but and then the really cool thing about it is that it is internet connected, so you can control it anywhere from an internet connection, and anybody who has an internet connection can control it. So
someone can hijack it then.
Yeah, I guess that would be
like a teapot.
So but that's what this does, and it was really cool for a while. It was working really well. It was working because we had internet, but this place doesn't have internet, so. Oh yeah, but we had to kind of bridge the thing, but I think some pins got pulled out. It was kind of like we just got everything wired right, kind of today. So it's kind of something we've been working on. Yeah, I guess everything is kind of broke, so and you can see it's kind of just taped together. Yeah, but it was really cool. It was doorstop.
Frankenstein bot doorstop.
So
it's a very fashionable one.
I'm excited. Once again, thanks everyone for coming. This was fantastic. I mean, it really was wonderful to see. We haven't had this kind of turnout before. So again, thanks everyone who made that happen. So a couple of prefaces. So I'm going to start with a couple of honorable mentions. Okay, and the honorable mentions are the two unmanned aerial vehicles that we saw. I think we're both really, really good. But the reason we're not going to award those is because they're going to be hard to demo live at preview day, either over at the MUB or here in the ERT. The quadcopter might work maybe, but I'm not sure. That's going to need some. So we're not quite sure what to do with that. So I think they were both quite good engineering projects, but we're not quite sure what to do with them. So we're going to put those as honorable mention and put those off to the side, and maybe we'll think about what we can do with those in the future. So I think who are those two? Okay, they were great. They both. It's more of an issue of how do we put this on a table and show it to a bunch of high school students. So that being said, third place, and we decided that we were going to award 2 third place. You don't have to split the prize money. We're going to do 2 of them, so there's actually 2 third place teams. So let me make sure I get this right. The third place team is team number 3, the internet-enabled LED controller.
Thank you so much.
And our other third place team is team number 2, the MIDI Orchestra, or MIDI. All right, so now only one of each on the first and second place. So, and our second place winner is team number 11, the automated resistor sorter. And finally, the moment you've all been waiting for, the winner of the first place Whirlpool Innovation Award for Masterpiece Mania this year is team number 4, Physical Spectrum Analyzer.